All right, so today we're looking at the product rule. I mentioned yesterday that the rules for adding and subtracting derivatives of different terms are pretty straightforward, right? The sum difference rule that we went over right here. If you have a term plus another term plus another term, and you're trying to take the derivative of that, polynomial of that expression, then if you're adding or subtracting, you just take the derivative of each one and you add up all those derivatives. That's easy. Okay? It's different, and I mentioned this, it's different if we're multiplying, and I just want to show you, today's lesson is this right here. I want to show you why that is. Okay? So 12x squared. Okay. I want to show you that 12x squared can also be written as 6x times 2x. Can also be written as 3x squared times 4. And there's other combinations, right? So we're just going to look at those three. Now, I'm going to separate them into columns here. Okay. And if we look at x squared plus 2x plus 1, we can rewrite that as x plus 1 all squared. Or, let's just make this simple. I don't want to get to the exponent yet. So x plus 1 times x plus 1. That make sense? X squared, 1x, 2x plus 1. Alright? So we'll just make a couple columns there. Alright. So I guess my point is this. I want to show you that you know how to take the derivative of this single term, right? And you take the exponent, you bring it down here, you multiply it by the coefficient that's already there. So that's going to be 24. And then x to the power of 2 minus 1, right? 24x. Okay? So it's a bit messed up there now, but you see that? Are you in agreement with that? Yeah? All right. Oops. So, that being the case, if we look at the factors, now remember, 6x times 2x is still the same as 12x squared. So, let's try and take the derivative of each one of these factors. Okay? So what's the derivative of 6x? 6. Good. And what's the derivative of 2x? 2. So the product of the derivatives is 12. Notice that 12 is not equal 24x. So you're thinking, well, maybe we just picked the wrong factors. What if we pick different factors? We might get this right. Well, let's try another set of factors then. What's the derivative of 3x squared? 6x. What's the derivative of 4? Multiply those, you get 0. Notice how none of those multiply to... Now, even 12x squared times 1, if we wrote that, it would still be 0, right? Because the derivative of 1 is 0. So we see that we have some real problems with products. What you've been doing so far, and I've asked you to find the derivative of this expression, right? And what you guys have done is multiply it together first, right? You distributed and you did your FOIL, whatever. You multiplied those two together, you got a polynomial. Then you did your product sum difference constant rules, right? I'm going to show you today how to get the derivative without expanding first. That's what the product rule is. It's saying if you have a product and you want to find the derivative of the value of that product, how do you go about doing that? Starting with the factors. So I guess just real quickly here, the derivative of this one, someone shout it out for me. What's the derivative of this expression here? 2x plus 2. Very good. Now, the derivative of each of these factors, that's going to be 1, and this one's going to be 1. So obviously, we see that we can't just multiply the derivative of the factors, right? Can't do it. So what we're going to have to do is come up with a rule. Now, I don't really know if I can just ask you to try and come up with your own rule. So what I'm going to show you, just to save time, partly, and because you could probably try all day, and some of you would just look in the textbook anyways, and just say, hey, I got an idea. Like on page 89, let's try that one. So what I'm going to do is I'm going to show you the product rule, and we're going to do a bunch of examples and just show you that it works for a bunch of different types of products. Okay? So the product rule, let's just get to it. And yes, it is on, well, I guess it's on page 89, 90. The product rule actually looks like this. If you have two functions, and we're just going to start off with two functions, so either two terms or two complete functions, that have multiple terms. But anyways, if two things are multiplied together and we're trying to find the derivative of them, then what we do is we take the derivative of the first and you multiply it by the second. Now, not the derivative of the second, just the plain old function that is g, not g prime, just g. So the derivative of the first function times the second. Add that to the first function by itself on its own times the derivative of the second. If you should memorize this, obviously, and if we're taking the derivative of a product, you take the derivative of the first times the second, plus the first times the derivative of the second. So if you just keep reading that through, keep saying that through, the derivative of the first times the second, plus the first times the derivative of the second. This is the power rule. And let's go back and let's check out our original example. So at 12x squared, and that actually equals 6x times 2x, right? And it also equals 3x squared times 4. So if we take a look at this, and I'm just going to put these in brackets, okay? You don't have to if you don't want to, but we know the derivative here is 24x. All right. So if we apply the product rule, and then we get this, the derivative of the first factor, right? Because remember, this is 6x is the first function. 2x is the second function. See that? Two things. We're going to start with two things. It works for more than two things too, but it's a little bit different. So we're going to start with just two things multiplied. So derivative of the first is 6. The second is just, we just leave it as itself right there. Okay? So that's the derivative of the first, see? Derivative of the first times the second. Then we add the first, which is 6x, times the derivative of the second, which is 2. If we expand and simplify this, we have 12x plus 12x. And voila, we simplify to 24x. See that? Alright, so that seems to work. I'm just going to take this other factor over here. I'm just going to move it over in a way now. So let's try with this one. Derivative of the first. What is the derivative of the first? That is, it's 6x, yeah, times the second, 4. Right? Plus the first, 3x squared, times the derivative of the second, which is 0. So what do we have? 24x plus 0. Okay? In both cases, two random factors, we use the product rule and we get the derivative. If we go back to, okay, let's go back to this one up here, and let's do the product rule to this and see if we can get this back. Okay? So it works for binomials as well. The derivative of the first is what? What's the derivative of this expression? Well, you got to look at each term individually, right? What's the derivative of x? 1. What's the derivative of 1? 0. So the derivative of x plus 1 is 1. Got it? Okay, so the derivative of the first times the second plus the first times the derivative of the second. You simplify that. Okay. This is going to be 1 times x plus 1. Oh, that's just x plus 1. Plus 1 times x plus 1. Well, that's just another x plus 1. Simplify this. You have 2 x's and you have 2 1's. So it's 2x plus 2. Okay? So for this example, what I'd like you to do is expand this product out to binomials, so FOIL, right? Multiply them, gather like terms, so that you have one single kind of polynomial. take the derivative of it. Then, over on this side, use the product rule to take the derivative of it, and I just want you to make sure that they are the same when you find the derivative using both methods. All right, so if you want to look up here, if you're done, check up here and just see if we did the same way or not. I did add some notation here. Here's the product, but I do want to take the derivative of it, so I just added the brackets with the derivative sort of indicator there. And when you multiply this out, do your FOIL method, right, you get this as a polynomial. When you take the derivative of each of those terms and add or subtract the derivatives, you get 30x to the fourth minus 6x plus 12x squared. And over here, if you use the product rule, you take the derivative of the first one over here, which is 6x times the second, plus the first one times the derivative of the second one. And you do that multiplication and gather your like terms. So here's the x to the fourth terms that would be able to be gathered there. And you should get the same thing. It's a little bit different order. If I did this in descending order, which is typically the way you should write it, descending order of the degree of the variable, and you see you have the same thing. Okay, questions about that?